In the mysterious borderlands between imagination and reality, there exists a shadowy realm where dreams crystallize into tangible creations. What was once merely a whisper in the mind of a writer has, time and again, materialized in our laboratories and factories, blurring the line between fantasy and actuality in ways that continue to baffle and enchant us. I'm your guide today through this enigmatic territory where fiction breathes life into innovation. Science fiction doesn't merely predict our future, it shapes it, molds it, sometimes even wills it into existence through an almost mystical process of creative manifestation. Consider the perplexing case of Jules Verne. In 1870, his fictional submarine Nautilus slipped beneath the waves of human imagination in 20,000 leagues under the sea. The vessel described with such precision, electric-powered, self-contained, capable of depths that seemed impossible at the time, wasn't just a fantastical creation. It was a blueprint whispered into the ear of the future. When the USS Nautilus, the world's first nuclear submarine, broke the surface of the water in 1954, it wasn't merely technological advancement. It was the manifestation of a vision that had incubated in our collective consciousness for nearly a century. The submarine's name was no coincidence, but a reverent nod to fiction's uncanny power to conjure reality. The haunting prescience of H.G. Wells casts an even more profound shadow across time. In 1914, Wells penned The World Set Free, describing atomic bombs that released continuous explosive power. He called this fictional power source atomic energy. Decades before the Manhattan Project, scientists split the atom. Leo Szilard, the physicist who conceived the nuclear chain reaction, explicitly credited Wells' novel for inspiring his breakthrough thinking. Fiction whispered secrets of the atom to science, secrets that would forever alter the trajectory of human history in ways both magnificent and terrible. Perhaps most captivating is the case of Arthur C. Clarke, whose 1945 paper proposed geostationary satellite communications, an idea that materialized in the Telstar satellites of the 1960s. Clarke, straddling the worlds of science fiction and scientific speculation, didn't just imagine our communication future. He calculated it, down to the precise orbital mechanics that would make it possible. The boundaries between the visionary writer and the visionary scientist dissolved in Clarke, revealing the intoxicating truth that imagination, properly directed, is perhaps our most powerful technological tool. Star Trek, that shimmering constellation of technological dreams, has proven especially potent in conjuring our digital reality. The communicator that Captain Kirk flipped open to speak across vast distances seems almost quaint now that we all carry smartphones with capabilities far beyond what even Gene Roddenberry envisioned. The tablet computers used by crew members, once seemingly magical, now appear strikingly similar to our everyday iPads. The universal translator that dissolved language barriers finds its echo in our imperfect but rapidly improving real-time translation apps. Even the ship's computer, responding to voice commands, has materialized in our homes as Alexa, Siri, and other digital assistants. But what makes this relationship between fiction and innovation so beguiling is that it isn't one of simple prediction and fulfillment. It's a mesmerizing dance of mutual inspiration. The scientists who bring these wonders to life are often themselves enchanted by science fiction in their formative years. Consider the enigmatic case of Jack Dorsey, Twitter's founder, who has spoken of how Star Trek's Communicator influenced his thinking about instantaneous global communication, or the engineers at Motorola, who explicitly reference the same device when designing the first flip phone. This creates a bewitching feedback loop. Writers inspire scientists who create technologies that then inspire writers to imagine even more advanced possibilities, which in turn challenge scientists to manifest ever more wondrous creations. It's a spiral of innovation that feeds upon itself, accelerating with each cycle. The boundary between the creator and the engineer blurs. Arthur C. Clarke was both. Elon Musk references The Hitchhiker's Guide to the Galaxy and Foundation as foundational texts for his thinking. Neil Stephenson, author of Snow Crash, now works with technologies his fiction once only imagined. Perhaps nowhere is this relationship more explicitly acknowledged than at NASA, where science fiction has long been embraced not as mere entertainment, but as a wellspring of inspiration and recruitment. The agency has held science fiction conventions and actively engaged with creators to explore the mysterious territory of what might be possible. In a profound acknowledgement of this relationship, the first space shuttle was named Enterprise, not after any naval vessel, but after Star Trek's fictional starship, following a letter-writing campaign by fans who understood that fiction and reality were already inextricably intertwined in our journey to the stars. Science fiction doesn't merely inspire specific inventions, it shapes the very direction of research and development. The concepts that captivate us in fiction often determine which technologies receive funding and attention. When a compelling vision captures the imagination, resources flow toward making it real. This subtle influence might be science fiction's most profound impact, not predicting specific devices, but creating the desire for certain futures that then drives innovation in those directions. We build what we first imagine is worth building. A smart home, that network of devices anticipating our needs and responding to our commands, finds its shadowy precursors in both the helpful and the haunting fictional AIs. From the murderous HAL 9000 of 2001, A Space Odyssey, to the benevolent computer of Star Trek. Our relationship with these technologies remains ambivalent, informed by both the dreams and nightmares fiction has planted in our collective psyche. We desire the convenience while fearing the loss of control. A tension first explored not in technical papers, but in speculative stories. Virtual and augmented reality technologies, now rapidly evolving, were extensively mapped in cyberpunk fiction decades before they became technically feasible. William Gibson's Neuromancer and Neil Stephenson's Snow Crash didn't just predict these technologies. They created the conceptual framework and vocabulary we still use to discuss them. The metaverse wasn't born in a corporate boardroom, but in the pages of fiction that saw both the promise and peril of digital realms overlapping with physical reality. Even our most advanced biotechnologies, like CRISPR gene editing, emerge from a culture long saturated with science-fictional explorations of genetic manipulation, from Brave New World to Gattaca. These stories didn't provide the technical details, but they prepared our minds for the ethical implications and possibilities. They created a cultural context in which scientists could imagine certain interventions as possible, desirable, or problematic, shaping not just if these technologies would be developed, but how they would be applied and regulated. In robotics, Asimov's 3 laws provided an ethical framework that continues to influence how we think about artificial intelligence safety. Real engineers grapple with these principles, not because they are technically necessary, but because fiction embedded them deeply in our conception of what responsible robotics development should entail. This reveals perhaps science fiction's most valuable contribution to innovation. It serves as a laboratory for ethical exploration, allowing us to experience possible futures before we commit to creating them. The cautionary tales of fiction, from Frankenstein to Black Mirror, don't merely warn, they help us navigate toward more humane implementations of powerful technologies. They are the wind tunnels in which we test the aerodynamics of future societies before building them. This places a profound responsibility on both creators and innovators. The futures we imagine may well become the futures we inhabit. The stories we tell ourselves about technology shape how we develop and deploy it. In this light, science fiction isn't mere entertainment, but a form of long-range ethical deliberation, helping us to envision not just what we could create, but what we should create, and how we might live wisely with our creations. As we stand at the threshold of artificial general intelligence, widespread genetic engineering, and space colonization, the dialogue between imagination and innovation becomes more crucial than ever. The visions we cultivate today will manifest in the laboratories of tomorrow. In this enigmatic partnership between the storyteller and the scientist, we find perhaps our greatest hope for navigating the perils and possibilities of accelerating technological change. A creative conversation that has already transformed our world and will continue to shape whatever worlds lie ahead.